Hi, and welcome to this video about Von Neumann Architecture and the Fetch Decode Execute Cycle. Computer devices all contain a central processing unit, or CPU, which is often said to be the brain of a computer device. The CPU carries out the instructions that are sent to it by performing calculations, making decisions based on logic, controlling input and output operations. Let's start by taking a closer look at the components that make up the CPU. The registers are small amounts of very fast memory that are used to store data required by the CPU as it processes instructions. There are a variety of registers, each with a particular function. The Memory Address Register, MAR. This is the register that stores the address to which data will be sent and stored within the CPU, or the memory address from which the data will be fetched from the CPU. Imagine that a textbook is the data, then the address would be the locker it is stored in. Memory Data Register, or MDR. This is the register that contains the data to be stored in the memory of the computer, for example stored in the RAM, or the data after a fetch from the memory of the computer. Again, this could be the RAM. The program counter. The program counter is one of the registers inside a CPU that stores the address of the instructions being carried out at the current time. Each time a new instruction is fetched, the program counter increases its stored value by 1. This allows the CPU to keep track of which instruction is being processed. If the program counter starts at 0, then the next instruction to be stored will be 1, and the next instruction after this will be 2, etc. The accumulator. This is another register found inside the CPU that is used for short-term and intermediate storage of arithmetic and logic data. For example, the accumulator could be used in conjunction with the ALU to add a sequence of numbers. It might start by adding 1 plus 1, which equals 2. Then it will do another calculation, say 2 plus 2 equals 4. Therefore, the accumulator will add those together and will have the value 6 stored. The control unit. This is an important part of the CPU. It directs the operations of the processor. It sends control signals to the computer's memory, ALU, and input and output devices. The two main elements of the control unit are the clock and the decoder. One instruction is carried out with each pulse of the clock. The decoder decides what to do with each instruction and sends signals to other components telling them to carry out these instructions. The Arithmetic and Logic Unit, or ALU. Data is passed to the ALU to carry out calculations and comparisons. The arithmetic part of the ALU carries out these calculations, for example, 1 plus 1 equals 2. The logic part carries out the comparisons, e.g., is 5 greater than 2? The logic part also carries out logic tests using logic gates. The results of the calculations or comparisons are sent to a register for storage. Each component within the CPU plays its part in the Fetch Decode Execute cycle. The first instruction is sent along a bus from the memory to the CPU, and the program counter is set to the address of the first instruction, which is 0. This instruction is copied to the memory address register. The control unit sends a signal to this memory location, 0. And the actual data is transferred to the memory data register. Cache is used to store a copy of this data. This is the end of the fetch cycle, and so the program counter increases by 1. The control unit decodes the instruction by comparing it to the instruction set it has stored. The instruction is transfer the contents of memory location 3, i.e. the number 3, to the accumulator. The control unit now executes the instruction and transfers the contents of memory location 3, the number 3, to the accumulator. The fetch cycle begins again. The memory address register copies the new address from the program counter, which is 1. The control unit sends a signal to this memory location, 1, and the actual data is transferred to the memory data register. Cache is used to store a copy of this data. This is the end of the fetch cycle, and so the program counter increases by 1. The control unit decodes the instruction by comparing it to the instruction set it has stored. The instruction is add the contents of memory location 4 to the contents of the accumulator. The control unit now executes the instruction and using the ALU adds the contents of memory location 4, which is the number 2, to the contents of the accumulator, which is number 3. The accumulator now reads 5. The fetch cycle begins again. The memory address register copies the new address from the program counter, which is 2. The control unit sends a signal to this memory location, which is 2, and the actual data is transferred to the memory data register. Cache is used to store a copy of this data. The control unit decodes the instruction by comparing it to the instruction set it has stored. The instruction is store the contents of the accumulator at memory location 5. The control unit now executes the instruction and stores the contents of the accumulator at memory location 5.